Welcome to The Explainer. Today we're talking about a traffic jam you probably don't think about, because this one's in space. We're going to dive into some fascinating research by Kevin L. Brown, which puts forward a forecast predicting when low Earth orbit might just hit a critical tipping point. So let's get right into it. First, to really set the stage, let's start with a number, over 1.2 million. That's how many pieces of dangerous junk, bigger than a centimeter, are whipping around our planet right now. Every single one of them is basically a tiny bullet moving at incredible speeds, just waiting to cause catastrophic damage. And that number? It's growing. This is the backdrop for everything we're about to discuss.
For the longest time, space was really just the domain of big governments. But not anymore. Now, it's a booming economic frontier. But as this new space economy absolutely explodes with activity, it's running headfirst into this huge and growing problem of orbital congestion.
So think of low Earth orbit, or LEO, as a new global commons, kind of like the high seas. It's where we've packed thousands of satellites, giving us everything from internet to GPS. The problem is, while the traffic is surging, the rules of the road are, well, informal and patchwork at best. What that really means is that satellite operators are constantly having to swerve out of the way to avoid disastrous collisions.
What's so interesting about this research is that we can actually measure this tension using something called a structural pressure index. And just look at the scores for traffic density and collision risk. They are both a 9 out of 10. That's incredibly high. It shows a system that's operating right at its absolute limit with very little room for error. And that institutional rigidity score of 7, that tells you the organizations meant to manage all this are really struggling to keep up.
So what does that high pressure score actually mean? Well, it's a huge warning sign. It signals that the current system just isn't sustainable. It's heading toward what this analysis calls a rupture, or a major transition. Now, that doesn't necessarily mean one single disaster, but it does mean that the old, informal way of doing things is about to break, forcing a new, more structured approach to managing traffic in space.
Okay, so if we know the system is under all this intense pressure, the big question is, can we predict when it will tip over into a new state? As it turns out, there's a specific analytical framework designed to do exactly that.
The forecast uses a model called Triune Harmonic dynamics, and it suggests systems evolve through 3 phases. Think of it like a quiet country road. At first, it's in a base phase, low traffic, easy coordination. Then it gets popular, and it enters a pressure phase, traffic jams, risk goes up, the rules start to strain. This is exactly where LEO is right now. Finally, all that pressure forces an integration phase, where something like a crisis or a big agreement leads to new, formal rules, like traffic lights.
So, that structural pressure we talked about, that tells us what could happen. This framework, from the researcher Kevin L. Brown, adds another critical layer, harmonic timing, which helps predict when. It's this model that's used to forecast a very specific window for a change in space governance.
And that brings us to the forecast itself, a time-bound prediction for when a whole new era of managing space is likely to begin.
The analysis pinpoints a broad window in the first half of 2028, running from late January to the middle of June, but it gets even more precise. Within that larger window, the framework identifies several shorter, 7-day periods where the probability of a system-changing event is at its absolute peak. You might want to mark your calendars for those.
So what exactly are we watching for in 2028? Well, the forecast is considered validated if one of 2 things happens in that window. The first is reactive, a major collision or an event that creates a huge new cloud of dangerous junk. The second is proactive, the signing of a formal binding international treaty for space traffic. One or the other, the disaster or the deal, would signal the predicted shift is here.
Now, this is maybe the most important part. A real scientific forecast isn't just a guess, it's a testable hypothesis. It has to come with clear conditions to tell us if it's right, but also, just as importantly, what would prove it wrong.
We don't actually have to wait until 2028 to see if this is on track. The model predicts we'll see certain indicators ramp up beforehand. Things like more public reports of high-risk near misses in orbit, stricter rules for getting rid of old satellites, and a real shift from voluntary guidelines to serious demands for binding international law. You can think of these as the tremors before the earthquake. And here's what gives the forecast its scientific integrity: knowing what would prove it wrong. It's weakened or falsified if our technology just gets good enough to absorb the pressure, or if 2028 simply comes and goes without a major collision or a binding treaty. This is what separates a scientific forecast from a simple guess.
So, the crucial point is this.
Low Earth orbit is a vital, shared resource, just like our oceans or our atmosphere. It's currently under immense, measurable strain. And according to this data-driven forecast, we are rapidly approaching a predicted tipping point in 2028, where the way we manage this resource will have to fundamentally change.
And all of this leaves us with a final, massive question. The forecast tells us a major shift is likely coming. The choice that remains is whether we get there through proactive agreement and intelligent design, or if we'll be forced there by reacting to a crisis. The 2028 window is fast approaching.